Hi everyone. Thank you for staying so late. It's been a long day for most of you. So I will be presenting Ethereum 2.0 testing and simulation, and the idea is that at the end of the talk, you know what has been going on in the implementer teams, you know a bit what is the life of Ethereum 2 implementers, and giving you some figures and if you want to play with Ethereum 2.0 tonight, for example. So, who am I? I'm Mamy. I'm part of the Nimbus team at Status, and I've been implementing Ethereum 1.0 and 2.0 in the past year. You have my contact details. So on Status, which is a mobile messenger, my name is Adolescent Full Mustang, and otherwise my GitHub and my Twitter. So, Ethereum 2.0. First of all, let's see where we are. I don't know if all of you watched Justin's in-depth talk this morning. So just a bit of a recap. The goal of Ethereum 2.0 is to improve Ethereum scalability. And how it does that will be in three, let's say, main phases: phase 0, phase 1, phase 2. What we have on Ethereum right now is similar to what we will implement on phase 1 and phase 2, but the big change will be phase 0, the beacon chain. And the beacon chain will have several responsibilities, like sharding, and also what is called proof of stake, that you can see there. And testnets are incoming, but not like testnets with everyone, but testnets for clients so that they can communicate within themselves. So the beacon chain is in charge of coordination, sharding, block processing, and lots of additional features that are very nice, like finality and RNG. So finality is just to make sure that once a block is finalized, you can rely on it and it won't change, like what we have in Ethereum 1, where we wait for 6 block validation to make sure that we won't have any change of the head block. RNG has been recurrent issues on Ethereum 1, like if you played with FOMO 3D contract, the RNG was kind of broken and exploited. Let's see about phase 1 and phase 2. Oh, disclaimer. Ethereum 2 is changing very fast, so I guess 30% of my slides that I did last week are already outdated. So I'll give you the updated by voice. So phase 1 will be about the data chain. So what's happening is that currently on Ethereum 1, we have some kind of world computer, but it's single-threaded. You have one thread that is running the EVM and all transactions on a single thread. With sharding, we will have 4,096 threads that are shards, and each one will have its own execution context, similar to the EVM today. So phase 1, currently the spec is written. You will see it's on this GitHub repo that also holds the phase 0 spec, but there is no implementation right now. And the responsibility is holding all the data. And so since the data is distributed, it should be much faster, like 4,000 times faster than Ethereum 1, except that we also have communication overhead. Phase 2 is about execution. So to make without phase 2, the data and the communication that we have is completely useless. Currently, it's still in discussion how to proceed from that. Like are we using EWASM? Are we using the EVM? Are we building another from scratch? And then we have further phases, but they can be implemented in parallel with phase 2. So like clients, which will can be done in parallel with phase 2. And phase 4, cross-shard transaction, because assuming we have 2 Ethereum chain, and I want to transfer money from one account on one chain to another, while we were on Ethereum 1, it's easy. It's the same chain, same responsibilities. But on Ethereum 2, you will have some cross-shard transactions and overhead. And apparently, there is a phase 5. So this part is outdated, sharding roadmap. So maybe we won't have a phase 5. It's called Ethereum 2 Endgame, and to be honest, I don't know what Vitalik has in mind, but you have some links in there. And actually, it's not the endgame. There is a phase 6, which is called super quadratic sharding with shards within shards within shards. So it's kind of inception, like, let's go deeper. Okay. So we now have the context. This is an old diagram of the Beacon chain and how it works. What changed since then is that, oops, I don't have, okay, what changed since then is that the main chain and the Beacon chain are now fused. And the blocks that you see at the top are finalized blocks, and you can rely on them for any cross-shard transaction. And you have another layer, the shard chain, and the VM that executes everything. And there is a very nice visual simulation that you can have at observablehq.com. At cdetrio Shasper v04. So, unfortunately, I can't run the simulation, but this will give you an example of how the Beacon chain progress. So here we have 1, 2, 3, 4, 5, 6, 7 blocks. And once the time pass, you have cross-shard transaction between several chains that are working in parallel. And the gold blocks are finalized blocks that are serving as anchor for any kind of transaction. So if you are still unsure and you want a visual demo of how the Beacon chain works, you should go there. Oh. So this is an easy visualization. But then there's the actual plumbing. So this was done about 3 weeks ago by a student called Proto Lambda. It's on his Twitter. On the slide, you will have, you can zoom out. And this is just the Beacon chain, phase 0. So why did I put something so illegible there? Is to show you how testing is important, because in everything there, anything can go wrong and impact consensus. But just before going into testing, let's go back to the past. So this is from 2013, vitalik.ca, ethereum.html. This was the spec of Ethereum. It fit in 1.5 A4 page sheet. And so, for example, Ethereum blocks were described with 4 sentences, like network. Ethereum will run on its own network with a memory hard proof of work. And people started to implement from that, like Gavin Wood. And in June, That was what we started with for the Ethereum 2.0 implementers team. Like we had Casper FFG, cycle operation, say the previous SBOC is justified, and we have 7 lines, and then we had to implement something and make sure that everyone, it worked together with everyone. We are currently 9 implementers team, so that's a big challenge. And to give you an idea of the life of Beacon Chain and Ethereum 2.0 implementers between June and September, the spec was done on a HackMD. We had commits, usually by Vitalik, that sometimes are very small and just changing words or fixing typos, and sometimes we had big changes. And we had to track that, like every 10 minutes we had updates, sometimes on Sunday, and what you were implementing was completely slashed and removed. And then, starting September, after some lobbying, we had GitHubs that started with commits, lots of commits, and people started to track everything, every changes, commits by commit. And starting last month, we had releases, so now spec is versioned. So this means that starting now, we can have tests with a specific spec version that we target, and make sure that everyone is talking the same language. And so now we're at the core of our topic. What could go wrong? What do we need to test? Don't do that at home. So we have multiple kinds of bugs. This is one way to classify them. We could have spec bugs, like off by 1, and it happened maybe 3, 4, 5 times, I don't remember. But especially on edge cases, like Genesis. We have vulnerabilities, like DOS attacks. For example, when you do Ethereum 2.0, you run a validator node for proof of stake. Assume your client leaks your IP address, and people just get your IP address and DOS you. And if you don't reply in time, the chain will slash your stake. And that's something that we need to be aware of. We have under-specification and interoperability. Like we had, if you followed Ethereum 2.0, we are using a new curve called BLS that is offering signature aggregation. And if we are not, there are 2 ways to do pairing. We have G1, G2 curve, well, that's crypto, and assuming we implement one way or the other, we cannot talk to each other because we don't have the same public key, for example. Or serialization, which is still being talked about for the network protocol. In terms of issues, we can have slowness, like, for example, currently, Vitalik released a new shuffling algorithm, but if you implement it the naive way, the shuffling is slower than the actual number of seconds you are allowed to propose a new block or attest on a new block. So you cannot implement the spec if you are just using the naive way. And you can have issues with incentives and game theory. But I think I'm pretty confident that Vitalik and the EF are doing well on that side. Now, for the implementation teams, you have overflows, underflows. slowness as well. You can also miscomprehend the spec and implement a wrong thing. You have vulnerabilities, and you have implementation details. And I will focus on that last part. So, implementation detail. Cryptography can go wrong. Peer-to-peer networking, signature, which is related to cryptography. Serialization can go wrong. Consensus, like your proof of stake is wrong. Syncing, if you request a new block and you get a malicious one, or you get timeout, how do you deal with bad peers? And you have your state transition, which is applying a new block and changing your state. So, a practical case. This is shuffling. If you search for shuffling on the Ethereum spec repo, you have plenty of issues. On the bottom right, non-determinism. Like, we can't reproduce your shuffling even if we start with the same data, which is very important on Ethereum. You have issues with light clients that are exposed to, I guess it's DOS attacks. What do we have? Issues in understanding the shuffling function. So spec miscomprehension. On the bottom left, we have out of bounds. So we have off by 1 in the shuffling. So, and this is a very self-contained example. So lots of things can go wrong. So this is a recap of what we had. Determinism issues, attack vector concerns, performance concerns, and out-of-bounds bugs. And every team, we have 9, are implementing their own clients. So we have 9 times the potential of bugs. So one question is, why so many teams are implementing clients at launch? While for if1, we had the team from Gavin on, I think it was in C++, and we had another team in Go at first. So one thing is that with so many teams, at least if there is a spec bug, everyone will encounter it, and it can be squashed much faster. Another thing is about decentralizing Ethereum. Don't rely on just parity or Geth, and have a lot of clients that are suitable for various environments, and make sure that we do not over-rely on a single implementation. So a link to all implementer teams. We have 2 clients in Java, 1 in TypeScript, 2 in Rust, 1 in NIM, 1 in Go, 1 in Python, and even 1 in Swift that started only 2 months ago. Everyone is targeting some kind of testnet by the end of March, and then once it works locally, we will be, I guess, talking about doing a testnet with multiple clients. So, everything on Ethereum 2 is organized on Ethereum 2.0 dash spec for the specification, and for testing, it's dash tests for the test vectors, and test generators for implementing, creating tests. So right now, everything that is stable and self-contained has been tested, so cryptography, shuffling, serialization. Coming soon are, state tests, and also proof of stake, what we call fork choice. Now, Ethereum 1 helped us a lot to not redo the same mistakes as before. One thing that was really helpful as the Ethereum 1 implementer was having a test repo that we could submodule, so we could just extract the testing. It was in JSON for Ethereum 1, which is very nice to work with in an automated way. The only thing is that when we reviewed the tests and wanted to pass them, we didn't know, because there was no comment, we didn't know if it was supposed to test an overflow, if it was supposed to test something that should work or that should fail, and if it failed, why. So for Ethereum 2, we will change to YAML for testing, because YAML allows comments, and also we could put some more structure on that. And the very big thing that we learned from ETH1 is that tests can generate an insane amount of lines of code to review. When I say insane, it's really insane. So this one is a very mild test from ETH1, and it generated about 7.5 thousands of line of code. And pick a number, like in your head, between more than 10,000, let's say. And in 5 seconds, I will change, and this is a crazy number of line of code that we in ETH1, and we didn't want to reproduce that in ETH2. So this is a test, a test generation in ETH1 that was 1.2 million of line of code, and well. Sometimes you also get a unicorn, because GitHub says this page is taking way too long to load. So right now, if I go back to the structure, what we review is just the test generators, and everything on the test is auto-generated with a Circle CI, and a bot will merge the new tests. So much less review issues. Now, I already went over what is coming soon. Regarding a cross-client testnet, so once we finish just client-specific testnet, we have pending the wire protocol, so I hope that we fix that in the next 2 months, let's say. Our wire protocol will be based only peer-to-peer. So first, we must make sure that we can talk to each other. And we already have a proof of concept for peer-to-peer testing that is available at this link, and that you can already use today if you want to play with Ethereum 2. And we have plenty of simulations. So the client simulation will be coming soon. This is what I call a full simulation with a real client. But we have a lot of high-level overview simulation, what I showed on previously. We have sharding simulation to make sure that we can manage the load on the network, and we have consensus simulation to make sure that proof of stake actually works. So this one I already described about 10 slides ago. Here is another one. This one is sharding simulation by the Barcelona Supercomputing Group. The UI is something that also works on ETH1 called ETH.NET-Stats. It's visible on GitHub. And this was a simulation to test how fast the blocks are produced with sharding and a proof-of-stake consensus layer. And it's available on Leobago ShardSim. And it's, if you subscribe to the YouTube channel every odd Thursday, for the Ethereum 2.0 implementers, it's talked about at every meeting. No, unfortunately, a lot of simulations are just console, and I guess that's one of the next steps that we all have to do on Ethereum 2.0 to appeal to people. But you have all those links, sharding NetSim, ShardSim, which I talked about just before, sharding P2P proof of concept, Wittgenstein from Consensus. You have Proto Lambda, LMD Ghost. So Ghost is for choice proof of stake. Vitalik has two simulations, one called clock disparity, which simulates latency on a network to make sure that we can have consensus even with latency issues. And White Block, which is a testing and simulation startup specialized in blockchain. They did simulation for Ethereum, Monero, Bitcoin, even EOS. And they are starting to open source their framework, and it can run with any client. So, assuming you want to start to work on Ethereum 2.0, there is a bounty, but unfortunately, I learned this morning that it has been taken. There was a bounty to implement the spec in Go, the Ethereum 2.0 spec, in less than 1,000 lines. The code will be released soon, and I guess 1,000 lines is very short, and you can play with that code and learn more about how Ethereum 2.0 actually works, and not just read the specs. Thank you. So, do you have questions? Thank you very much.